a group and user basis, but also at an attribute level. So you'll see that in the demo, and we can talk a little bit about how that's done in the solution. So I'll pop this up. I will say as well, we do have a live demo. This is pre-recorded, so apologies for that. I just wanted to make it real timely for you guys. So this will just be high level, but if you want to get into it or get into the code, whatever you want to do, we'll be around to talk about that. So I'll just.
All right. So for the sake of the demo, I'm going to walk you through a really simple use case using Ada. Imagine that you're a business analyst at an e-commerce company, and you want to see if there's a correlation between the recent COVID cases and their online site visits. So we're going to use Ada to join and analyze two data sets in different formats from different source locations. So once you deploy the applications, users will log in through a browser-based interface. And you'll land in here, which is where I'll start the process of ingesting the data sets that I'll be analyzing. So first, to do that, I'll need to create a domain. And a domain is essentially a logical grouping of data sets. It could be anything like a team, such as sales, marketing, maybe project focus. Essentially, it's just a file folder. I've already done that for the demo, so I'll just go straight to pulling in the data set. So I mentioned before, we have 6 pre-built connectors to common data sources, and the one that I'll be using today is from BigQuery. So I'll select that here, and this is going to be the online site visits. And you'll notice that there is a button to automatically detect PII. So this will detect in that data set if there's anything like an email or phone number that you want to redact from visibility to users. So I'll select that. And then this will be where I essentially am pulling in the service account details. So from BigQuery, I've previously ran a query that I want to fetch the data from. So I'll just do that, along with specify the service account details and the data import window. So I can either run that on demand and manually trigger any updates that will fetch the data, or we can schedule that. So it might be hourly, daily, weekly, etc. So this one's just on demand. So I'll move forward. And now this will go through the process of crawling the data set to inferred schema. And what's happening in the background is we're using an open source tool called AWS Data Wrangler, which will shorten the feedback loop for the schema inference, as opposed to crawling the entire data set with something like Glue. And by doing that, users will have the ability to catch any errors they have in the data set early on in the process and apply transforms before going through the entire ingestion lifecycle. So once this completes, this will provide users with a preview of the raw and inferred schema, mapping the columns to the inferred data type. And it is a sizable data set, so just taking a second here to infer that schema. All right, so now that's done, and this will see look at the column within the data set and match it to the associated type. You can also go in and look at the information there and see if there's anything that you might want to transform. This one's all right. I'll just continue with that and press submit, which will kick off the job to create the infrastructure and run any transformations that need to be applied to the data set. So while that's being imported, I'll also go through and create another one. And this one's going to be my online, this is going to be the recent COVID cases. And that's sitting in a CSV file on my local machine. So I'll advance forward, select that, and this will go through the same process of inferring the schema. So with this one, let's say that I don't like the date column. It's in Australian format. Maybe I want to change that. So I can do that through transforms. And we have a transform planner, which has both pre-built and custom transforms that can be applied. So let's say that you wanted to drop some of the columns in the data sets, or if it's a JSON document, maybe you want to relationalize that. You can do that here and stack those, or you can kind of build your own. And this is done through Python. So And I think I've already previously done this. So you can either write the Python script, or you can pull in a file with that. And I have one here. And what this is going to do, similar to the schema inference, this will actually apply that transform and generate a preview in the data set. So you can see if that's been properly applied. And also, these transforms are saved and can be shared across the organization if it's something common that you'll use once again. All right, so that's been successfully applied. And you'll see this column's been changed. It's a bit messy, but that's okay. All right, so we'll go through now and press submit again. And also what's happening when we're creating that infrastructure is it's also creating tables in Athena, which is our query execution mechanism, which will allow users to instantly query the data set as it's being created. So while that infrastructure is building, you can analyze the data set direct. So once this schema is generated, we'll be able to do that. All right, so we just go to the raw schema here, and then let's say I want to run a SQL query that will aggregate the number of COVID cases by date. Use some SQL to do that. And like I said, this is using Athena in the background to execute the query. And it also will apply governance rules. So, let's say that I'm just a power user in the group, and I don't want to have access to a variety of different information that is sensitive. Those governance controls will be applied. For this one, it's pretty simple. It's just the date and the COVID cases. So that's done successfully. And we can save this to be referenced later. So you just go here and specify what domain it is. And this is the COVID cases. So when I press submit, this will actually be available publicly to anybody that has visibility of that data set. So it's here. And you can also reference that by name alias. If you're running a complex query, you can apply those and kind of join queries together to create a materialized view, which saves some time and effort. I talked about the governance rules. So here, you'll have the ability to see those happening in action. I'll go to a different one. And so you'll see, that in the data set, the user email has been detected with our PII detection system. So for the actual governance rules, let's say for email, I have the ability to change that based on the user level. So by default, everything's going to be hashed. But if you want to change that to, maybe it's hidden for default users, it's hashed for power users, and it's clear for admin. You have the ability to do that, along with create your own governance policies.
Data supports natively connecting to third-party visualization tools through the Athena JDBC ODBC drivers. So I'll use the same results from the query that I ran earlier, looking at the number of COVID cases and site visits to demonstrate that. So to connect to these tools, we'll first generate an API key to form that secure connection. In this case, I'll be visualizing the data through Tableau. So just defining the expiration date, and this will generate that API key. So I'll go ahead and copy that and paste it here. This is the Athena driver that's within Tableau. And then just add a secure access key, 4-digit PIN, and this will form the secure connection to Ada. And by doing that, you'll see that all of our domains have flown through, along with the associated data products. So I can go ahead and inspect this data to look at the table. And also just to note, the governance rules will apply through in that data product when inspecting the data. And then I'll just take that query that I ran earlier
and generate a report. So once again, this is looking at the number of COVID cases and site visits by date. And in this case, we see a positive correlation. So our job here is done. And hopefully that gives you an idea of what you can do with the platform and the kind of use cases that it provides.
Cool. All right, passing to Warren now to talk about what was actually happening throughout that sequence.
Thanks, Kyle. I hope that it's not confusing you. As you can see, there was a lot going on, and when we're building the platform, there are so many angles to take a platform, and we kind of made it such a way that's opinionated so that we can focus on serving a very specific use cases. But as we go along, we can possibly extend it as well. So we build a very flexible kind of architecture frameworks. At a very high level, we basically wraps around 20 plus AWS services in a event-driven serverless microservice architecture patterns. You've seen we have a standard kind of user interface sits outside AWS console, deployed through this CloudFront, which interacts with the backend services through the API gateway. And some of the core services you've seen, like query and search, or the execution of Athena queries, all wrapped into these Lambda functions that basically ensures there's no stale infrastructure components or resources around. Some of the key parts of this product which is the data product lifecycle management. When we design it in such a way that all the infrastructure that's related to a data product gets basically dynamically deployed. So you don't have any stale infrastructure running around. That including a step function that orchestrates the lifecycle of a data product from ingestion all the way to egress out, and all the functions and for glue jobs, for crawling the data and transforming the data, all dynamically deployed. So if you create a new data products, you deploy the product infrastructure, and when you retract the infrastructure along with it. So it's very dynamic along with the entire deployments. Of course, there are many other components like the securities and the WAF and the egressing components, which will route a custom kind of egress proxy that's translating JDBC commands into ADA specific HTTP APIs. I'm not going to dive all into that. I'm going to focus on the journey of the data products for the purpose of this meetups, because that's the meaty part of the entire solution. So you're probably seeing there's the first part of the data product creation phase, which through the wizard configurations, there's a schema preview. What's behind the scene is that we basically use AWS Data Wrangler to, we pull in the data from the destination, from the source data, whether it's S3 or it's externally to the AWS environment like Google Clouds, Google Storage Analytics, all these external sources, and we pull a sample of that through the API calls and into a local S3 storage. Then we run the schema inference using AWS Data Wrangler, which will generate all the schema you've seen, like the data types and the sample data through that. The idea is give that feedback loop to the users so they know what they're importing in rather than wait for Glue to complete half an hour later. And then we discover any transformation that's required along the way. You might have a very nested JSON structure that you want to relationalize for easy query down the line. So we have built-in transformation that converts that into relationalized JSON data, and also like converting data formats for better query and better storage formats down the line. Then we run any transformation through the transform planner. So whether it's a custom script, if you're an advanced user, you know how to do Spark Pythons, and you can ingest any of your own script, or you can use our built-in Glue transformation library that was in part of the library, and then that creates the whole schema preview processes. Questions? Okay, I'll give some time for the question in the end. Then for the actual creation of the data product, so once you go through the schema preview process, like the wizard configuration, you're comfortable with the data you're importing, you hit the submit, we actually fork 2 parallel processes at the end of the submission. The first part, which obviously deploy, as I mentioned, we deploy dynamic infrastructure that orchestrate the workflow from ingestion all the way to for the query, for PI detection. Any sensitive information will be potentially masked, for encryption. But at the same time, because that process can take a long time. And when we talk to the analysts, a lot of time they say to us, okay, for some of the S3 data, they might already reside in the environment, or CSV data, they want to get a quick turnaround to get, run some transformation at the SQL level. So they don't have to wait for the Glue transformation to complete, right? So you can do both in a way. So we build this parallel process, which essentially using the schema that was inferred during the preview process and drops straight into Athena external table so that you can query directly through Athena without going through the glue crawling processes at the end. So that provides a mechanism for this immediate feedback loop. And especially for the first time when you're importing a data, there's a lot of experimentation, there's a lot of trial and errors to see what the data you're importing is what you wanted. So this part of the process handles that immediate feedback loop for the data analyst to get a query on hand in SQL format. So for the actual data importing process, we build a lot of reusable components. Obviously, for each different data sources that we have different essentially ECS tasks that's responsible for the importing of the data, whether it's BigQuery or data analytics, or we have CloudWatch coming, and all these different connectors that importing data lands in S3. But once it lands in S3, the rest should be following the same kind of processes, like you run a glue crawler and then transform the data, and it goes in a loop where if you have nested structure, you might have to crawl further once the structure being relationalized. Then we update the glue catalogs, whether it's an update process or if it's a brand new replacement on top of the data, we run all these blue-green deployment process so you don't get interrupted when new data automatically flows in. So you just, next time you run a query, you get updated data straightforward. And then at the end of the entire process, we run PI detection. We use comprehend, which we send the data into the comprehend, a sample data, so you don't get massive bill, to the comprehend, and the comprehend basically returns back the classification for the data. Any sensitive data will be ultimately mapped into your governance rules. You've seen the demo that you can configure the dictionary level to say you want to hide or hash email based on the user that's running the query. And we do this as a masking mechanisms to mask the data. We took a very different approach in terms of the query and the governance. If you're familiar with things like late formation, for example, a lot of the governance components was done by propagating the policies down to the IAM level for the source data. We took a different approach. I'll come to the why in a bit, but basically for the query, when you write a query and execute it, there is translation happening behind the scenes. There is domains and there's data products, which is local to the application level. But when we before we pass this to Athena, we use a Presto SQL parser, which converts the query into entities, and then these entities basically gets translating to the Glue database and catalogs. And that ultimately gets mapped in before we send to the Athena. But along the way, we also run these hashing functionality in user-defined functions. Rather than a fixed snapshot of the, rather than hashing the data on the raw side, we hashing the data on the fly. This is to provide this kind of the data consistency, especially when you're doing joining against the different kind of entities. A lot of time you have issues, you hash the data, but when you join this data product with another data product, you lose the relationships between them, right? It could be user ID, product ID. So we build this consistent hashing mechanisms to ensure that when you joining this data together, you maintain a relationship between the query and the source data. And we also add, on top of that, there's a lot of security measurements into this, like we add a salt at account level to prevent these rainbow table attack scenarios as well. So this prevents that from happening. So governance can be configured at both the column level as well as the row level. Column level obviously mapped to the dictionary. We use the hashing at the column level for masking or hashing the data. At the row level, you can see that where age is greater than 12, that's the row level filtering you can pass through the governance rule to say, I only want to hash the data if the age is more than 12, 21 at the row level. So that's what we built in as part of the dynamic governance part. So hope that all makes sense. There's a lot going on under the hood. I've kind of walked you through a journey of a data product to deep dive into each part of the component and step flows. Any questions?
Round of applause first of all. For the question, either we'll pass around this lapel, or we'll get the presenters just to repeat the question. Any questions? I'll just.
Quite a lot of text back on there.
Can I just give you this?
Formation. You've got cloud formation, you've got Lambda, you've got API gateways, the whole lot in there. Do you have like a cost calculator if I have to take this to an exec team and say, how much is this going to cost us?
Yeah, you will see our, well, you can talk about it. We have a public implementation guide, and like any solutions library, we document the scenario-based costs breakdown across all the services. We've actually done pretty exhaustive measurements around different types of scenario, like ingesting data continuously for a month to calculate, for 1 gig, 1 TB worth of data coming and query at routine frequencies, and how much does it cost you at the individual service level. So we do have that. You can find it on our ADA implementation guide website from the solution library.
Just quickly, going back to kind of the construct of Beta, it is serverless, so you're not paying when you're not using it. So for ad hoc queries, it's a real nice tool to have. But based on those calculations, so kind of like a small user might be around $600 USD. Middle-sized user is somewhere around 11, and then I think the higher range is about $3,000. So that's just rough estimates. We are working on a dynamic calculator as well that, given these usage scenarios, look at the costs.
Actually, worth mentioning, we built the cost explorer into the application as well. So specifically, so every resource is tagged against ADA. So actually, we can show you in the demo that there is a section in the application called the cost, administration cost, and you can actually see how much it costs you from 30 days, 60 days, 90 days perspective. And a breakdown into different services.
I'll just pass the lapel. Might be worth repeating the question regardless, just so that the rest of the room can hear.
Hello, this is a simple question. What kind of connectors are coming up?
So there's a question around the built-in connectors. We have 6 built-in connectors, 3 internal AWS services integrated and 3 external. So we have S3, Kinesis, Fireflow, and then we have Google BigQuery, Analytics, and Google Storage. That's the other box for the current MVP. And we have a slide afterwards for the roadmap. So Kyle would love to talk about that.
Yeah, just quickly. So right now we're working on RDS, CloudWatch, CloudTrail, and DynamoDB. And then we're also in conversations with Talend. Part of that is Stitch, along with Fivetran. So you will have kind of the ETL tools that are out there that solve kind of the connector problem. And as mentioned, I don't know where that roadmap slide is, but we also have a connector framework that we'll publish in our next release, which is essentially a way to create your own connectors. And we hope with community contributions that will just grow and grow. But right now, I guess the default is S3. But we're keen to hear what you guys need as part of the listening process.
The part of the transformation is by Glue, yeah? If I want to replace that for Amazon EMR, for example, is it possible?
So the question is, can we replace Glue with EMR? And the short answer is no. So, as I said at the very start, we took a quite opinionated way of integrating these solutions. So Athena is one of them. You can see that Athena, because we use the Crystal library, which is what behind Athena, and the query, when it gets passed and compiled down to Athena level, it cannot be easily translated to, let's say, Redshift, because Redshift has a serverless now. At the time of building it, there's no Redshift serverless. So we took an approach on serverless architecture and making sure there's no stale. So if you want to replace Glue with EMR, we're more than welcome for your contribution to the open source project. We did build this into a very kind of decoupled way. You should be able to, like we have a connector framework, for example, you can easily just take that and build your own connectors around it. So similar to the Glue component, which essentially is orchestrated through a stack function, right? So if you want to replace that with the dynamic infrastructure, so if you want to deploy that through, let's say, EMR tomorrow, there's two parts you will need to consider. One is the static part, which is the cluster, and there's the dynamic part, which is the instance when you run these tasks and you want to scale this up. So that's the kind of the decoupling mechanism built into the product. So any time you want to replace it with external tool or different tools, that you can do that.
Yeah, this. Thanks.
I was just interested in that sort of community and that open source language you were using before. I mean, are you, as a contributor, are you writing to an API? Are you building to a framework? Are you providing low-level UDFs? I was just wondering if you could expand on that community angle.
Yeah, great question. So the question is, do we have any community-driven framework that makes the developer easy to contribute to projects? I would say yes and no in a way. So we've done a lot of refactoring work at the end of this project, essentially to bundle the connected framework into one, co-locate into one specific area. And it's very easy for you to pull down the project and start to write your own connectors, and you can easily navigate around. We have a lot of documentation around how to write your own connectors too. We don't yet have a full-blown API or kind of the CLI tool or developer-driven tools that allow you to just kick off and kind of template it in a way using automated mechanisms. It's definitely on the roadmap. What we envision this to be is very similar to, you'll see, like Airflow, for example, they have their own custom connector framework, or Tableau has connector framework, things like that, very much along the same trajectory for building a community-driven APIs. I mean, we are very early stage for this project, and any ideas on the community you have, and we're very open to listen to. Yeah, we have really, yeah.
I was just going to add, so the connector framework is the kind of the first big bit that we want to solve for, just given that there's so many different data sources that are out there. But our intent is to make the entire application modular. So we're breaking down those microservices into components, where you'd have kind of like the primary data engine as one that we maintain, but for each of the other ones, where it might be UI or it might be transforms, you have that microservice component, which you as a community member would be able to influence. So that's still kind of on the roadmap and horizon. We'll get there, but yeah, we're still listening.
Rasheen, do you have anything to add? So Rasheen is the engineer behind these connector frameworks too.
I guess just adding on to the open source, it's released as a solution. We're actively communicating with anyone who raises an issue or puts a comment. So if you have any ideas, just on the GitHub page, and we'll be very responsive.
Yeah, cool. It's seems any more questions? I was just gonna. Okay, do you want to have a follow up? Yeah.
Do you have CloudFormation support or Terraform or any?
Yeah. So I can definitely speak to that. So we have every AWS solution is deployed through a CloudFormation essentially. So if you go to our library, the solution library for ADA, you can one-click deploy that through CloudFormation. We also have CDK support. You can deploy the entire solution through CDK, CLI, if you need to. Yeah. That answers the question.
Takes about an hour to deploy. So it should be pretty straightforward for you guys. Yeah, I know we're out of time. I've included a QR code that's to the landing page if you guys want more information. There's also our implementation guide on there, GitHub repo. So we'll leave that up for a second, and then all of our emails are on the other side. So please do reach out. I'd love to talk with all of you about kind of the use cases that you're working through now and how we can work together in the future. So thank you, everybody.
Round of applause. All right. Up next, we've got Praveen Kumar. So while he's getting set up, I'll just give you a bit of an indication of what to expect. How many of you, by the way, came to Data Eng to watch the live stream? Show of hands. A couple of people. All right. Not everyone, right? Okay, fair enough. That's okay. I won't take it personally. Maybe. But yes, and so we've got a few Glue users in the audience, which is always good. And what did you think? Thumbs up or thumbs down on Ada? I think it's a really fantastic tool, isn't it? It's pretty exciting to see sort of the innovation happening, the simplification of perhaps lake formation deployment. Ada just really impressive. All of these sort of same defaults that it offers. So Praveen Kumar is a analytics solutions architect. He's going to be taking us through interactive data integration with AWS Glue. So I could probably give you a bit more of a spiel, but he's a specialist solutions architect at AWS with expertise in designing, building, and implementing modern data analytics platforms using cloud-native services. His areas of interest are serverless technology, modern cloud data warehouses, streaming, and ML applications. Sounds amazing. Are you nearly ready there, Kumar?
Yeah,
Praveen?
Almost. Sorry about that. All of my browser have expired, so should be good. I'm going to be doing live demos, so that's what I'm just trying to set up. All right, just give me 1 sec. Should be nearly ready.
Yeah.
Okay. Let me know if you can see it. Yeah.
Awesome. And by the way, in a couple of weeks, we should have most of the videos from Data Eng Bytes, our data engineering conference that we hosted in Melbourne and Sydney. We'll have all of the videos from that live on our YouTube channel. So stay tuned for that coming out pretty soon. But sounds like you're ready to roll, Praveen.
Thanks for that. All right, let's get started. Thanks for the introduction, Peter. Mic. We'll have to stand here. You can see the slides. Yeah. So hi, everyone. As Peter already introduced myself, so I've got about 2.5 years of experience at AWS, but my background has been BI, data warehousing, and AI ML workloads. So today we are going to cover interactive data integration with AWS Glue. So Kyle and Warren and Raheem sort of covered a solution, which is a higher level solution that uses a lot of this infrastructure. So we talked about Glue, Athena, potentially some of the CloudFormation stack. So we're going to look at AWS Glue, which is our serverless data integration service. So I'm going to spend about 15 minutes talking about some of the challenges, some of the trends, introducing AWS Glue for those who are not familiar with AWS Glue. Then we'll look at today's focus is going to be the various UI options within Glue, right? So I'm going to cover that, and specifically focusing on interactive sessions and notebook support, which we announced earlier this year. And then I've got demos. So time permitting, I've got 3 demos for batch workload, streaming workload, and ML workload. But we'll see how we go, right? Okay. So Kyle already sort of covered this, but I just wanted to point out a couple of things here. The 3 V's of big data is still there, right? The data has been generated at a very high velocity. Of course, the volume is increasing at an exponential rate, and also the variety. So structured data, semi-structured data, unstructured data. So the problem still remains. But the other thing I want to talk about is as data platforms are moving to cloud, we have got various different kind of user personas who wants to interact with the data platform. So, previously, if you think, data pipelines, or for that matter, reporting, dashboarding, it was a function of central IT team. But now we see line of business users sort of wanting to interact with the data platform. We have got, advanced users who prefer their own sort of experience, kind of notebook type of experience. So we have got a growth in terms of that diverse user personas as well. And then the need to analyze applications is also growing. So, we have got batch workloads, streaming workloads, and sort of we're building ML applications on top of it. Specifically for data integration in terms of the challenges that we see customers are facing today. So if you think from IT execs and sort of platform managers, when they talk to us, they call out the pain points related to sort of lock-in. So very sort of conscious of what stack they invest in. Multi-persona support, again, as I said, data engineers could have varied skill set, and also they're dealing with expensive data integration solutions. In terms of data engineer group itself, you have got scalability issues when you build pipelines. So ensuring that when you build a pipeline, it can scale to process huge amount of data. So that's scalability issue. The infrastructure management, you don't want to be managing infrastructure. You want to focus on the value-added services. And finally, from a business perspective, lack of options in terms of self-service data preparation, but also if the pipelines are not stable, there is missed SLAs in terms of reporting and dashboarding. So at AWS, to solve for that, we offer AWS Glue. So I might do a quick show of hands. So I couldn't see, how many of you have used AWS Glue before? So roughly 20%, 30%. And how many of you have used Apache Spark before? Oh, roughly the same audience. All right, so AWS Glue is our serverless data integration service. So one of the first thing to note is completely serverless. And so what you do is you just write your transformation logic, and then you select how many nodes you want to run that on, and you can kick off the job. And what happens behind the scenes is sort of Glue manages all of the infrastructure. Your job can get started in a matter of seconds, and whatever processing logic you have written will get executed in a serverless manner. And in terms of processing power, it can scale up to thousands of workers, right? So that's something to keep in mind. It also had got some of the recent announcements with regards to auto scaling, so it can process spiky workloads. There's a flex option. If you are not familiar, it sort of saves you cost up to a figure of 30% if you don't have fixed SLAs. And then in terms of UI options, while the platform and the engine is powered by Apache Spark, however, you get 3 sort of high-level UI to interact with. So for those who are not familiar with sort of writing code, PySpark, or for that matter in SQL, there is a nice visual interface where you can do boxes and arrows, right? And there's some pre-built transformation. But for those advanced users, we also have a notebook experience, which is going to be the focus of today's session, and I'll do demo on how to use that. It's cost effective. Serverless technology normally are because you're only paying for when it runs. And there's no lock-in given it's Apache Spark powered. You can write your code and take it and run on the Apache Spark supported compute. So what does AWS Glue includes? AWS Glue is more than Apache Spark. It's kind of end-to-end data integration service. So you can imagine as you're ingesting data from number of data sources, AWS Glue offers you 100+ connectors. So you can connect to things like RDS, on-premises data, cloud-based solution, and also sort of streaming services, right? So that's more of connectors you can use out of the box. The next thing, when the data lands in S3, you want to discover the metadata. So while you can manually create metadata, which is your table definitions and database definitions, Glue comes with Glue Crawler, which is kind of an agent that you can run on top of the data in data lake and sort of extracts metadata. So you can kind of automate that whole thing. And then once you have extracted the metadata, which is your database and table definitions on top of S3, you need a place to store that metadata. So that's your data catalog. So again, that's a serverless, like every other Glue functionality. That's also a serverless offering where you store all of your metadata, that is your database and table definitions. And the heart of AWS Glue is that sort of transformation section where you can process, terabytes and petabytes of data. Right, so we will talk about that section in detail, but I just wanted to cover Glue Studio Notebooks in the interactive session, which is a recent release. And then with that sort of stack, you can build your modern data platforms. All the challenges that I talked about earlier in terms of no lock-in, expensive, multi-persona support, AWS Glue sort of helps you solve all of those challenges. All right, so coming back to UIs, so there are three main UIs. There's a Glue Studio UI. So if you're not familiar with coding, you can just go and use this visual editor where it's sort of drag and drop. So it has got all of the sources, destination, pre-built transformation. You can write your SQL, and you can also write some PySpark code if you want to. And behind the scenes, Glue generates Apache Spark code, right? But you sort of interact with that same engine through the visual editor. There's a Glue Data Brew at the right, which is sort of targeted towards business users. So Data Brew doesn't have any coding involved. It's kind of point and click. So if you have got within your business line of business users who want to do self-service data preparation, that's when you start looking at Data Brew. Again, it's powered by Apache Spark and Glue infrastructure. And the focus of today's session is in the middle, right? So prior to interactive sessions, and I'll cover interactive session in detail, if you have to develop a Glue job, you'd normally sort of use development endpoint, which has kind of an EMR cluster in the backend, right? So to spin it up, it used to take 10 minutes, and then you build your pipelines, and then there's no sort of auto terminate and all of that. And so interactive sessions helps preparing data or building your data pipelines in a very sort of interactive manner, as the name indicates. And it's also integrated in Notebook, which is what we are going to see today. So coming back to interactive session, what it does, as I covered, it sort of reduces your time for first query from 10 minutes to seconds. So you can get started very, very quickly. The second thing is you have a choice of what sort of ID you want to use. So you can use Glue Studio Notebook. But if you are today using PyCharm, IntelliJ, because interactive sessions is a bunch of APIs. So you are able to integrate that with Glue Interactive Session. So it's targeted towards rapid Spark development. So Interactive Session lets you spin up a remote Spark environment in a matter of seconds, right? And it uses the same infrastructure that powers AWS Glue. It's pay as you go, so not it's a serverless. If you don't use it, you're not going to pay anything. It has got a nice cost control where you can specify idle time. So if you say idle time is 10 minutes, if there's no activity for 10 minutes, it will automatically terminate itself. You can also select number of workers. So that could be as low as 2, which means you are saving on the cost. And RESTful. So that's the key part. Glue Interactive Session, if you think about it, they are on a bunch of APIs. So what are those APIs? It's as simple as this, right? So if you have got access to AWS SDK and you have got an AWS account, you can pretty much make these API calls and spin up an interactive session environment. So create session, as the name indicates, it spins up a Spark environment, which is sort of isolated so that you don't get noisy neighbors problem. Run statement is when you have written a Spark code, you can send it and it sort of executes in that Spark environment. Get statement getting the results back, and stop session is killing that session. What that means is you can use it in your own applications and sort of interact with your data sets using powerful Apache Spark compute. To make it even more easier and to take the power of interactive session closer to the user, we also released a Jupyter kernel on top of Glue Interactive Session. What that means is if you are currently using Jupyter Notebook, it's easier to use interactive session. And it also enables integrating with other IDEs like PyCharm, IntelliJ, and Dataspell. If you have heard about Spark Magic, it's a really cool way to sort of, use configuration in your code itself. So as you can see here, you can, with Spark Magic, you can sort of have the job to run in a streaming mode. You can set up a worker type. So there are a couple of worker types in Glue. You can specify connections. You can specify Glue versions. And the benefit of this is you can take this code and run it, in any sort of environment, and also carries your configuration. So the experience is quite consistent. All right, so that was all I had in terms of presentation. As I'm going to focus more on demo so that it's more intuitive. So just give me one sec. So I've got 3 demos in place. One is batch workload. So suppose if you have got a use case where, you have got a marketing data set and you think it might have a PII data. And your organizational requirement is you don't want to store any PII data in data lake. So how do you solve for that? So that's what we're going to do in this next section. So I've got a data set created. It's a marketing data set. I've stored it in S3. So what that looks like, this is in that raw folder. So I'll just quickly show what the data contains. So as you can see, it has got some marketing details like fields like, page views per visit and total web visits and so on. It's at a per user level, and there's a phone number at the end, right? And I ideally want to automate this process. So if you're ingesting data from any of the sources, you can use Glue connectors. And in the process, if you identify any PII data, you want to detect that, hash it, and write back, a cleaner version of the data. So to do that, this is the Glue console for those of you who have not used before. And this is the Glue Studio tab that I was talking about. So once you click on that, it opens up this page. And if you go through the job, these are the various options that you can use to interact with Glue Engine, right? So the first one that I talked about is more sort of visual option. So, if just to demo this, if you choose this option, you have got way to visually create job. So you've got these various sources, what sort of transformation you want to do, what sort of target. And again, optionally, you can write some code because there's some there's a transform to write SQL. Should be somewhere here. SQL query, or you can also write some PySpark code. But this is again targeted towards those BITL developers who don't have sort of any PySpark background. But today I'm going to talk about this option, which is the notebook, Jupyter Notebook. So as part of Glue Studio, that's available. So you click on that, and when you spin it up, it opens up this Glue Studio Notebook. So these are the various magic available that sort of helps set up configuration of the Glue engine. So what I'm doing is I'm just going to load some library that's kind of boilerplate. Once you create a notebook job, it sort of comes pre-populated. So it has sent a create session API call, right? So now it's waiting for a session to be created within Glue. So it takes about a few seconds, and you can make this call from sort of any other application or environment. So hopefully this completes soon. But let me walk you through rest of the code. Here I'm reading a data set. So the session has been created. So it hardly takes about 10 to 20 seconds. Then what I'm going to do is I'm going to read a data set. The data set that I showed you, I created a catalog table in Glue that points to that data set. And I'm going to run that query. So now I am just executing those two API, which is run statement and get statement. So once this finishes, it's going to print the schema. So as you can see, it printed the schema, including the phone number. Next, I'm going to do some printing of the result set itself. Again, the interactive part is the cool part because that's where you can make changes if you need to modify transformation and things like that. So you can get a quick view of the data set. As you can see, this phone number is populated. Next, you can run some aggregation and calculation over this data set. So you can use SQL. So this this magic command allows you to write SQL in this cell. So here I'm aggregating data for a lead source, and I'm doing just sum of total visit. So simple SQL statement. All right, so once this completes, now I'm doing PI detection. So Glue has inbuilt transformation to do PI entity detection. So I'm passing these 5 categories, but you can pass more. So let me execute this. What it's doing is it's sort of scanning the data set for any of this entity. There are a couple of key key parameters here. One is 0 to 1 indicates you are scanning the entire data or portion of data, so sampling. And 0.1 is if the 10% of data or more is identified as PII, it sort of identifies that column as PII. If it's less than that, so it's kind of threshold. So it identified there's a phone number, which is a type phone number. So then you can quickly write a Python function to sort of hash it. Okay, and so it has hashed the data. And finally, once the data is hashed, I'm going to write it into S3 location. So that location is within Glue Studio PI transform. So let me go to that S3 location. So in here, if I refresh, let me check where it has written. Okay, so it's directly in the bucket. So I need to go one level up. So you can see PI transform. And this is the data set that we have written. It's written just now. So I'm going to do a query with S3 select. It's CSV, and I do run SQL query. So it might be JSON. Let me check. Yeah, it's a JSON file. So I'm going to select JSON option here. And run SQL query. Right, and the phone number is hashed. Now, the best part of this is you have built this pipeline end-to-end very, very interactively. In order to sort of productionize it, you can just create it as a job. So it's a one-click deployment to a pipeline job, right? So very, very handy. So that was kind of the end-to-end sort of development in terms of PI detection and handling, right? Okay, so my next demo is on streaming workload. So this is batch workload. So Glue, Apache Spark has got structured streaming where you want to process data in sort of near real time. And so I've got this architecture in place. Let me take you through this architecture. Can you see the slide? Yeah. So what I'm going to do is I'm using Kinesis Data Stream, which is our serverless data streaming service, to process, capture, and analyze streaming data at scale. So I've got this Kinesis data stream created. I'm going to send, artificial data set. The use case related to contact center intelligence. So I'm going to generate some data in Python and going to send it from my laptop through Kinesis data stream API calls. I have got a lookup table in S3. And so what I'll do is I'll use the Glue streaming and an interactive session to sort of read data from Kinesis data stream, then read data from data lake. I'll then join them. I'll do some aggregation. I'll do a tumbling window, which is kind of non-overlapping window, and I'll do some calculation on top of it. And I'll write back to S3. Once data is written in S3, I'll create a data catalog on the top, and then Athena, which is a serverless query engine, goes and queries that data, and I've got QuickSight at the end to show the visualization. Right, so this kind of end-to-end. You can imagine a scenario where a use case could be, as I talked about contact center intelligence, we have got calls coming in related to campaigns, and you want to analyze that data in real time. You want to see, how many calls are dropping, what's the campaigns, or how the campaigns are going, how many are completed calls, and so on. So let's now do this in action. All right, so I might have to log in a couple of things just because this session timed out. Happens all the time. So let me open up some windows. And I'm going to send start an API call. So this is S3. So what I'm going to do is I've got a custom script which I'll execute. This is sending some data into Kinesis data stream, right? So as you can see, the data set is agent ID, what is the sort of call status, campaign name, and so on. So this is going to Kinesis data stream now. And then the next what I'll do is open up Glue, which is where I'm sort of writing that streaming pipeline by reading data from Kinesis data stream as well as S3. So let me open up interactive session. And I'll also make sure I have got no data in there. So when Glue streaming job starts working, we see a new folder getting created here. And then I also need QuickSight. So QuickSight is our serverless data visualization tool, which is quite easy and to get started, and sort of has connectors to Athena and so on. All right, so Glue Studio, and I'm going to open this streaming notebook that I've written, and I'll walk you through it while I've got everything set up. So let's imagine there's a dashboard, which is all about contact center intelligence. So I've got some campaign trains, completed calls, dropped calls, and so on. So currently there's no data. I can also set auto refresh. So it's auto refresh now. As you can see, it refreshes every 10 seconds. And then let me open up this notebook server. All right, so the first thing to note is I've used the magic for streaming, which sets the job to be a streaming type. I'm using the latest version of Glue. I can set the number of workers here. So you can go as low as 2 or as high as, hundreds and thousands. Again, both batch and streaming supports auto scaling, so you can enable it here. This is boiler code, so I'm just going to run this, and this will create a session for me. So again, I'm using the power of interactive sessions to read data from Kinesis data stream and data lake and interactively develop a streaming pipeline. So it should create a session soon. Now here is a lookup table in S3. So with Apache Spark, you can sort of unify your lookup tables in S3 as well as streaming data set. So once the session gets created, I'm going to read this lookup table in a data frame. And what this lookup table is, it has got additional information of the campaign. So I've got a campaign ID here, which is campaign code. So it has just got lookup. It's currently showing a lot of none, but there are some values as well. Once that's done, let me take you through while this session. Okay, session just got created. So I'm going to run this lookup table. It stores, it will show the results of the lookup frame. And then next is I created a Glue data catalog that points to the Kinesis stream, right? So that's the next one. So in order to build a streaming pipeline, I need a kind of a snapshot of data set. So this is what this is doing, right? So I'm taking a 10-second window size, which is kind of micro partitioning in Spark. And then I've got a polling time in 15 seconds. And so what I'm doing is taking a snapshot of a streaming data set, and sort of this opens up the streaming to read data for 10 seconds, and will create a sample data frame. That's what this is doing. And this is useful to sort of interactively develop a streaming application. So that's what I'm doing. It's currently reading to Kinesis data stream, and it's creating a static data frame. Again, this is something that's available with interactive session. Then next is where the processing happens. So this is where we are transforming, building that processing logic in terms of transformation. So as you can see, I'm using tumbling window where I'm doing some group by, and you have to specify windows and things like that. So I'm going to run that. And then I'm joining this data set with the lookup table that I earlier read. So that's a kind of processing logic we are doing. So what this will tell me is last 10 seconds of whatever window time I've set, how many calls are dropping, what sort of insight I'm getting from campaign level and things like that. Once that processing logic is working fine, then there's just these two blocks which is used to operationalize it. So this is kind of a boilerplate function which is required for sort of operationalizing and deploying into prod. But I'm using the same logic what was at the top. So I'm going to create this function, and then this is what is used to sort of running it on an ongoing basis. So until now, I shouldn't have any data in S3. I shouldn't have anything in QuickSight. I just want to make sure. So you can see there is no data. So I'm going to kick it off now. So this streaming job has kicked off. I can sort of create it, as I said, one click deployment. But the streaming job has kicked off, and now I should soon start seeing. Okay, so the data set has started arriving, and let's see how long does this take for the QuickSight to refresh. All right, so the data has started to appear in the dashboard. This should auto refresh. I'm not sure what's happening there, but the QuickSight you can set auto refresh in the Chrome browser. It's an extension that will show you the updated data. Right, so that was a streaming workload. I'll see how we are going with the time. We're going good. And then the last section is how you can do ML workloads using Glue Interactive Session. So we'll talk about it specifically on feature engineering. So I'm not going to go into a lot of detail, but I'll just quickly walk you through, sort of notebook. Because it's a bunch of APIs, you can use it through SageMaker Studio Notebook. So what I'll do is open up SageMaker. So SageMaker is our fully managed machine learning service that enables you to build, train, and deploy machine learning models for a wide range of use cases. So you go to Studio. I'm going to launch the app. Data scientist. No, this one. But what we are going to do is do some feature engineering using Glue Interactive Sessions. So SageMaker Studio is integrated with Glue Interactive Session, which means if you have to do feature engineering at scale, again, you can use the same sort of notebook experience, set the configuration, use Apache Spark ML library to process the data, and then write back into S3. And then once the data is written in S3, you can use one of the pre-built algorithm in SageMaker to sort of train your model. So this is opening up a notebook for me. So I've got a notebook created, and I'm going to quickly walk you through that. So again, as you can see, this should be familiar. I'm in SageMaker now. So for personas as a data scientist, ML engineers, there's one place to go where they can sort of still use serverless infrastructure of AWS Glue, use interactive session, and do feature engineering here. So I think I executed it. Yeah, okay, so this is running. So I'm doing the same thing. I'm reading data set from that S3 location. And this is what I'm doing. So if you are familiar with feature engineering, here I'm using Apache Spark library to do things like a string indexing, one-hot encoding. This is just to prepare data for machine learning because it sort of works optimal on numbers. So I've executed that. Then I just create a pipeline, again, using Spark ML library that sort of executes this in sequence. And once that runs, I'll show you what the feature looks like. So this kind of sparse vector. I'll do some cleaning if there is an existing data set there. And then here is where I am saving the data set that I have engineered through this notebook into S3 location. Once that's done, you can just use a Python and SageMaker APIs to train your machine learning model. So I won't execute because training takes about 2-3 minutes to run. and deployment also takes about a minute to run. But this is where I'm reading data where I've written before. I'm going to create a training job. I'm then going to do a deployment, endpoint deployment, and then I'm just doing some accuracy check. So at the end, accuracy would be 86%, and confusion. This is the confusion metrics, and you can delete the endpoint from here. So that's kind of all three workloads: batch, streaming, feature engineering, ML workloads. You can all do all of this utilizing Glue Interactive Session, and so really accelerates pipeline development as well as you use the same infrastructure that powers AWS Glue. On the slide pack again. So the key takeaways are, Glue Interactive Session lets you build your data pipelines in a easier manner. It's faster and cheaper, given you can control cost. Again, as I showed through Glue Studio Notebook, you can do end-to-end data integration, whether it's batch, streaming, or ML. And you can, if you're already using an IDE of your choice, you can still interact with Glue Interactive Session. That's it for me. Any questions?
I'll bring around the microphone. Sorry. Here we go.
Thank you.
Loud voice as well.
All right. Thanks for that. That was really cool. As someone who's been stuck in the hell of firing up dev endpoints even until recently, I really need to start using this stuff. But yeah, particularly with the streaming, I'm just trying to get my head around what's actually happening in Glue and how you're getting charged for that. If you set up a streaming job, is that an ongoing cost, or is that on data processed?
Yeah, it's you select number of workers. So you pay based on number of workers. So there are two worker type that you can use for batch, and you can also use for streaming. But we recently introduced another worker type that's like a smaller 1/4 of your G1X. So you can choose the right sort of worker type for how much data you're processing. The second thing you can do is enable auto scaling in streaming, and sort of that with your workload, it can go up and down, and so automatically handles that sort of spiky workload.
Cool. Okay.
Try not to kick too many bottles down. There we go.
Thanks. Just continuing on that question. So when the looping happening every 15 seconds or so that's the worker start to kick in every 15 seconds, or is it stay online throughout?
Worker will stay online. It's because Spark works on micro batching. So it's kind of that streaming is opened to read data for 15 seconds before it can send for processing. So it's kind of that window time. It's the window time when it reads the data.
Some other questions? One more, Howard. Mate, great. 1 second. Great shirt, by the way. I think that's. Where did you get that from?
I forgot. Can you remind me?
Data Eng Bytes, of course.
So what if the processing time is greater than the micro batch time? What will happen?
Yeah, so there will be queuing, and that's why you need bigger
workers.
Power to process it in that window. In fact, you should have, we have a best practice block. You should be able to process in 60-70% because there would be some overhead in terms of all those jobs, and so the processing needs to take care of at that time so that you don't sort of go over.
So can you automate the scaling process?
Yeah, so that auto scaling works in the sense, but you still need to be careful with what window time you select. If you sort of always goes up, then again there's value in keeping that as static workload.
So if you can increase the window time as well.
Sorry.
You can increase the window time.
You can increase the window time. Yeah, that's the setting that you apply. Yeah.
Cool. Any other questions? Otherwise, a massive round of applause for Praveen.
Yeah, so if you can fill up a session survey, just 2 questions, I'll really appreciate it. Will help us improve for next meetup or next sessions.
Yeah, feedback is very good, and feel free to provide some feedback to the Data Eng meetup as well. As mentioned, we've got some videos coming out shortly for the Data Eng session. We've got our next meetup coming soon as well. Another great shirt on you as well. Well done. There's actually heaps of swag left over from the conference, so ping me if you wanted a shirt from Data Eng Bytes. I've got a few spares at home, maybe a couple of boxfuls. And yeah, look, you don't necessarily need to be a solutions architect to present at this meetup. We're open for speakers across the community. If you're first starting out with your journey in data engineering, or if you're a seasoned expert or somewhere in the middle, you're most welcome to put forward the talk. So just feel free to reach out to one of the organizing team. Should have our next meetup announced in the next couple of days, so that should be a lot of fun. And perhaps you're from a company that's keen to host the data engineering meetup, so feel free to reach out to us about that as well. As long as you've got, decent sized space and able to put on some pizza or something even more delicious, then you're most welcome. So thanks so much. We're going to stick around for about half an hour to do some networking, and see you next month. Thanks so much. Cheers.
Thanks, Peter. Thanks for coming.
All the Glue Interactive Sessions, the SageMaker. Do you actually get charged for the SageMaker?
Yeah, man.